Alright, in this video I'm going to be showing you an example of how to solve a polynomial inequality. So I have a polynomial here, x to the 5th plus 3x to the 4th minus 10x cubed, and it's set less than or equal to 0. So I want to know for which x values will this polynomial be less than or equal to 0. So let's think about what we know about polynomials. I do know how to graph a polynomial like this by hand based off of some patterns with polynomials. And if I can create a picture, then if I want to know where it's less than or equal to 0, I can kind of translate this in my head to I want to know where that polynomial is below the x-axis, because less than or equal to 0 means my output, my y values, would be smaller than 0, so they would be below the x-axis. And since it says equal to 0, it would be below the x-axis or on the x-axis. We want to include values that are also on the x-axis where it would be equal to 0. Okay, so let's see where this is happening. And essentially every time I have a polynomial inequality, I'm going to start by graphing this function like we've done before based off of the characteristics of polynomials. So let's start with our end behavior. If I look at my first term, I'm already looking at my highest degree and noticing that it is odd. And I'm looking at my leading coefficient, 1, and I'm noticing that it is positive. So I have an odd positive, and in my head, I'm picturing that. I know that on the left, it's going to be headed to negative infinity, and on the right, it's going to be headed to positive infinity. So when I draw my graph here in a second, I'm going to make sure it's going down on this side and up on the other side. Okay, now all I need to do is fill in the gaps in between. So I want to figure out where are my roots, where am I going to be touching or crossing the x-axis. So I want to take this polynomial that's in expanded form here, and I want to try to factor it. Now anytime I have something to like a 5th power, I'm going to first start by looking at all the terms and seeing if they have anything in common that I can factor out. And I notice they all have x's, and they all have at least 3 x's. So I'm going to start by factoring out an x cubed. For the first term, it would leave behind an x squared. Second term, plus 3x. And the last term, minus 10. X to the 5th, plus 3x to the 4th, minus 10x cubed. Looks good. Okay. Now if I want to finish factoring, now I have a quadratic, which is nice. So I can factor my quadratic like we've been doing all year. I want to know two factors of negative 10 that add up to 3, and I believe that positive 5 and negative 2 will work. 5 times negative 2 is negative 10. 5 plus negative 2 is positive 3. Great. So I have x minus 2 on this side and x plus 5 on this side. So my final factored form of this polynomial would be x cubed times x plus 5 times x minus 2. All right. Once I factor it, that helps me to find my roots or zeros where this is equal to 0, because I can think about these separate factors and think what x values would make them 0. So this one I have x equals 0, because 0 cubed would be 0. This one I have x equals negative 5. Negative 5 plus 5 is 0. And the last one I have x equals 2. 2 minus 2 is 0. So these are going to be the places that I'm going to be touching or crossing the x-axis. So let's go ahead and draw our picture of what we got so far. We've got negative 5, 0, and 2. 1, 2, 3, 4, 5. 0 and positive 2. And remember from earlier, my graph should start down at negative infinity and end up at positive infinity on the right. So I'm going to start down here. I'm going to cross through negative 5, cross through 0, and cross through 2. And remember that at any point I could also just touch or bounce against these points. But in this case, I'll kind of rewind a little bit. All 3 of these factors had odd multiplicity. So the fact that I crossed through those points is correct multiplicity. If any of them would have been squared or to a 4th power, then I would have needed to touch that point rather than actually crossing through it. Okay, so this is generally a sketch of what my picture will look like, but let's make sure we actually answer the question. It wants to know for what x values, when is this inequality less than or equal to 0, and we said earlier that means where is it below the x-axis or touching the x-axis. So I see that this part of the graph is below all the way up to this point right here is touching. And then this piece of the graph is also below with these 2 points touching. So these are all the x values that I want to describe now in interval notation. I want everything to the left of -5, so all the way from -infinity to -5. And I'm going to put a bracket rather than a parenthesis because at -5 we're equal to 0 and we want to include 0. If that equal sign was not there, then we would change this by putting a parenthesis. Union, then I want this second piece over here, and this piece goes from 0 to +2, and again I'm going to put a bracket for both because I want to include those values because those are the values that make the graph equal to 0. Everything between those values is less than 0. So this interval right here would describe exactly where this polynomial function is less than or equal to 0.